Everyone. Today's lesson covers a topic called binomial expansion, and I think you'll see in the first couple of examples what we mean by that, but what I really want you to go into this thinking is that this is really meant to be a shortcut for you, and I'm hoping to convince you with these first couple of examples we do that it is a shortcut. There are pieces of it that are going to feel like, oh my gosh, it takes forever, but really once you get the hang of it, it moves pretty quickly. So I just want you to go into this with the right mindset. So first, let me kind of explain what it means to do a binomial expansion. We all know what binomials are. Binomials are, polynomials with two terms. So like right here, I'm using x plus y as a binomial. And we've worked with binomials before. So what we're doing with an expansion is taking a binomial like this and raising it to a power. So you've done ones like this quite a bit where I have like, I don't know, x minus 3, the quantity squared. And then you would lay out two parentheses side by side and you would FOIL. So I feel like you're probably going to be pretty comfortable with kind of these first three. Once we get down here to the power of 3, I think you could do it. You would know what to do. It's just going to take a long time. And by the time we get to like a power of 4 or 5, it's going to get pretty cumbersome. So usually I have you guys in class do a little bit of an exploration here, where I have you actually try to work through these and see how far you can get on your own. I'm going to spare you that right now and just kind of show you. But so x plus y to the power of 0, we know anything to the power of 0 is just 1. And then x plus y to the first power is just x plus y. Okay? So x plus y squared, we know we would have to write out as x plus y times x plus y. We would have to do FOIL. And we would go x times x is x squared. I would get an xy here on the ends, and then I would also get an xy here in the middle. So my outsides and insides are both xy's, which means I have two xy's. And then on the end here, y times y would give me a y squared. So this here would be my final result. I got that from doing FOIL. Okay, so for a power of 3, that would mean that I would have to do x plus y times x plus y times x plus y again. And there's really no shortcut to this. What I'm going to have to do is I'm going to have to multiply these two together first, which we actually just did up above. So we know that this is x squared plus 2xy plus y squared. And then I would have to take that and multiply by x plus y here. So that's going to be a lot of distributing, right? So I'm going to take x squared and multiply it here and here. And then I'm going to take 2xy and multiply it here and here. And then I'm going to take y squared and multiply here and here. I'm going to have 6 terms all together, and then I'll start combining my like terms. So you can see what I mean, that this is getting to be a little bit cumbersome to have to write this out this way. I will just tell you, I can do this in my head, and I'm going to try to convince you today that you can too. But this is going to end up looking like this. X cubed plus 3x squared y plus 3xy squared plus y cubed. Now, right now you probably have no idea how I did that, and that's okay. I'm telling you, this is what you would get as a result if you did go ahead and do all of your distributing and then combining like terms. So, for example, x squared times x gives you x cubed. And then here you're going to end up with an x squared y. And then here, when you do 2xy times x, you're going to get 2x squared y. So altogether, that gives you 3x squared y, and so on. Okay. I'm trying to talk you out of doing this in this lesson. So that's why I'm not going into a great amount of detail here. So now let's think about this next one. X plus y to the fourth would be like x plus y times x plus y times x plus y times x plus y. Now, you could make the argument here that we already know, because we just did it up above, we already know what x plus y cubed is. So we could take these 3 out and replace with this, and then we would just have one round of distributing to do. But let's assume that I hadn't given you the rest of these problems. Let's assume that I just asked you, what is this thing? Think about what you would have to do here. You would have to FOIL these two together, FOIL these two together, and then take the results of both of those and multiply all of those together, you're going to end up here with, let's see, at least 9 terms, I think. And then those 9 terms, you'll combine all your like terms. I will tell you, by the time we reach like a power of 4, there are very few people who can work through all of that FOIL without making a mistake. Okay. I've seen it, because when we take the quiz on this, there will always be somebody who says that what I'm teaching is too complicated and they would rather just FOIL their little heart away, and they'll try to plow their way through this, and it almost never works. Okay, mathematically it works, but there's always somewhere where someone makes a mistake, because it's just too many things to keep track of. But again, I'm going to astound you with my mathematical prowess here, and I'm going to tell you that I know what this will work out to be. It'll be x to the 4th plus 4 x cubed y plus 6x squared y squared plus 4x y cubed, and then plus a y to the 4th. Okay, so I want you to start looking at some patterns. Okay, and some of you might have started to catch on to what I was doing there. But I want you to take a look at patterns. And before we do that, I'm going to go ahead and put some 1s in here as coefficients. So this is 1x plus 1y. This is 1x squared. This is 1y squared. These 1s just kind of help us see the pattern a little better. Okay, so in this first one, let's just look at coefficients for a minute. I see 1. In the next one, I see 1 and 1. In the next one, I see 1, 2, 1. I see 1, 3, 3, 1. 1, 4, 6, 4, 1. So I want you to think to yourself for a second. Where have you seen this pattern of numbers before? Where does this come from? Where do these numbers, where are they generated from? And I wish I had one right here to show you. Oh, I do. This should look like our old friend Pascal's triangle. Look at what we have here. We have 1. Oops, it's too zoomed out or zoomed in for you. In that first row, we have 1. Then we have 1 and 1. Then we have 1, 2 and 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Okay, so the first observation you should be making is that whatever power it is you're raising your binomial to, the coefficients come from Pascal's triangle. So if I asked you to do x plus y to the 7th power, you could write out x plus y 7 times like this and do a ton of FOIL. That would be like a full page worth of FOILing there. Or you could generate the 7th row of Pascal's triangle, which actually isn't on my diagram here. But it would be, I don't know, 1, 7, 21, 35, 35, 21, 7, and 1. Okay, remember Pascal's triangle, you add the 2 above together to get the next term. So that's where that's coming from. So I could generate my coefficients that way. The next thing that happens is take a look, and this probably gets to be, you probably won't notice it until here. Look at your x's. We went from x squared to x to the 1st, and then this one had no x's at all. That's like an x to the 0. Here, if I look at my x's, I have x cubed, x squared, x to the 1st. That would be like x to the 0. Here I have x to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. Okay, so whatever this first term is, the powers are going to descend starting from whatever power this is. Okay, so again, if I was doing x plus y to the 7th power, I would start with x to the 7th, and then my next term would be x to the 6th, my next term would be x to the 5th, and so on. At the same time that that's happening, look at what's happening to the y's. If I start here, this one has 0 y's, right? That's like y to the 0. This is y to the 1st. This is y to the 2nd. Here I have 0, 1, 2, 3. Here I have 0, 1, 2, 3, 4. So while the x's are going down in degree, they are starting at the highest degree and working their way down, the y's are starting at 0 and working their way up. Okay? So I don't know if this is in your notes. This is basically what we just said, kind of written more formally, okay? If it's not in your notes, you may want to pause the video to copy it down because I probably won't wait long enough. But if I give you something like this and I say expand it, and you don't want to FOIL, which I would recommend against, I would say, try not to. I mean, when it's little like this, go ahead and FOIL. But starting at like a power of 3 and beyond, I would be using this trick, okay? So if you're doing a plus b to the power of n, start with row n of Pascal's triangle. Now, if you just have to generate a random row of Pascal's triangle and you don't know what it is off the top of your head, remember we can use combinations, okay? So if I needed to know what row 7 looked like and I didn't have a diagram of Pascal's triangle sitting in front of me, I could start by doing 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3. I could generate that row. We've already practiced that. Okay. Then whatever this term is, whatever A is, we're going to put that in each term in descending orders of exponents. So we're going to start with a power of whatever n is, and we're going to work our way down. Now, notice that I put that A in parentheses. That's going to be really important, and you'll see when we actually work through one of these, that this number here, whatever it happens to be, I mean, in this case, it's an A, but putting those in parentheses is going to be a really good idea. It's really only going to make a difference when you're working with negatives, but the negatives can really screw you up if you're not careful. So just be careful. Okay, and then you're going to take the B term, which is the second term. That's going to go in ascending order of exponents. So we start with 0. The first term won't have any of whatever that is. And then we're going to work our way up to whatever that n exponent is. And then this is the part that, I mean, it really just goes straight in your calculator, but this is where we have to be careful about order of operations and typing things incorrectly in parentheses and all of that. We'll simplify our terms. So let's try it. We're going to do x plus 4 to the 5th power. So my very first step here is to generate row 5 of Pascal's triangle. Now you might know row 5. Some of these you're going to do so many times that you're going to get used to what they are. But let's suppose we didn't know what row 5 of Pascal's triangle looks like. I'm going to show you how to generate it. Sorry, I'm just trying to make it so you can see my calculator at the same time. So I know row 5 is going to start with a 1 and then a 5. Okay, because that's how all of our Pascal's triangle rows start. So this would be 5 choose 0. This would be 5 choose 1. So I'm actually going to start with 5 choose, no, 5 choose 2. And there's my next term. It would be 10. Okay. Then I'm going to do 5 choose 3. And I get 10 again. So remember, there's that symmetry in Pascal's triangle, right? So if I get 2 in a row that are the same, I know that from there my terms are just going to go backwards. So this is going to go 1, 5, 10, and then 10, 5, 1. Okay, I didn't space those out super equally, but this is row 5. And notice there are 6 terms in row 5, okay, because of that 0 term thing. And again, this, I mean, you could have done 5 choose 0, and this would have been 5 choose 1, but I hope that you'll know these first two off the top of your head. So that's step 1. And by the way, you're going to see me using lots of colors here. You may want to choose to use multiple colors when you're writing these out the first time. Okay. And I'm going to go ahead and put plus signs in between these just to make sure we can define where our terms kind of start and stop. These numbers are our coefficients. So these are the numbers that are going to be like in front of each term. So now I'm going to take this x and put it in descending order of exponents. And since it's just an x, I'm not going to worry about the parentheses piece. The parentheses piece is really only important with numbers. But so I'm going to put an x to the 5th, x to the 4th, x to the 3rd, x squared. This one gets an x to the 1st, and then this last one doesn't get an x at all. And then the last piece, and I'm going to see if this color shows up for you. If not, I'll switch it. Now I'm going to take the 4 and put that in ascending order. So this is going to be like 4 to the 0. This would be like 4 to the 1st power. Okay. This is going to get a 4 squared. Notice how I wrote that. The parentheses around the number and then the square on the outside. This is going to get a 4 cubed. This is going to get a 4 to the 4th. And then this last one is getting 4 to the 5th power. Okay. So now what we need to do is clean up each of these terms. Now this first one, that's pretty straightforward, right? That's just going to stay x to the 5th. For this next term, and I'm going to kind of demonstrate doing this in my calculator, even though I don't think you would need to do this in your calculator. Really, the math that I'm doing is 5 times 4. Okay, so I'm going to do 5 times 4 in my calculator and get 20. Again, hopefully you wouldn't actually need a calculator there. So that's going to be 20. And then I still have this x to the 4th sitting here. For this next one, I'm doing 10 times 4 to the power of 2. Okay, so 10 times 4 to the power of 2. Nope, power of 2. And that's 160. And then I have my x to the 3rd. Here I'm doing 10 times 4 to the power of 3. 10 times 4 to the power of 3. I think that's going to be 640. Yep. So that's 640 x squared. Here I'm doing 5 times 4 to the 4th power. And that's 1280. And then right there at the end, all I'm really doing is 1 times 4 to the 5th power. I know we don't really need the 1, but again, just making a point about how to type these into my calculator. And that's 1024. Gosh, you would think I would have learned my spacing lesson, but I didn't. Okay, so this thing that I wrote down here in purple would be my final answer. And you obviously wouldn't have to have quite so much space in between there. But that's what this thing would be if you wrote it out 5 times and foiled it. And again, this is meant to be a shortcut for you. The hardest part about this is putting these pieces together at the end. Almost always, I have students who know what they're supposed to do. They know how to generate those pieces. It's the combining the pieces at the end that gets to be troublesome. So just take that real slow. Make sure you're leaving yourself lots of space to write this out. Don't be a hero and try to, cram this into as small of a space as you possibly can. It's not going to do you any good. Okay, let's try another one. And maybe you want to pause and get a head start and see, although this one I do think is trickier. Okay, so first thing we need is row 6 of Pascal's triangle. If you have a diagram of Pascal's triangle handy and you want to just look up row 6, that's fine. I'm going to generate it using my calculator. So I'm going to say, I know it's going to start with 1, and then the next term is going to be 6. Okay, and then from there I'm going to do 6, choose 2. Because remember, this is 6, choose 0. This is 6, choose 1. So 6, choose 2 is 15. Okay, now I'm doing 6, choose 3. And I get 20. 6, choose 4 takes me back to 15. And so from there, I really should be able to fill in the rest of the row. So 15, and then 6, and then 1. Okay, at least they're spaced a little better this time. I'm going to put my plus signs before each one of these. Again, that just helps me tell apart my terms when I'm going to put them back together at the end. And now I'm going to take this first term, which is a 2x, and remember that is going in descending order. So I'm going to have 2x to the 6th power. Notice how that's written, the 2x in parentheses with the 6 on the outside. And then I'm going to have 2x to the 5th power, 2x to the 4th power, 2x to the 3rd power, 2x squared. This is 2x. And then the last term doesn't get 1 at all because that's like a power of 0. Okay. Now let's do the negative 7y. Attach that negative right to the 7. Okay. This one's going to be super important that you have it in parentheses. Remember, the first term doesn't get one. The second one starts with negative 7y, and that would be to the first power. This one gets negative 7y to the second power. This one gets negative 7y to the third, negative 7y to the fourth, negative 7y to the fifth, and then this gets negative 7y to the sixth. Okay, right here at this step, you should be able to check your exponents by making sure that every term has a total degree of 6. So, and 6 because this is a power of 6. So notice this one has 6, this one has like a 5 and a 1. This one has a 4 and a 2, a 3 and a 3. So that's one way to check right here to make sure that you haven't made any mistakes in laying out any of these pieces. We're going to talk about how to put it in our calculator in just a minute. I also want to draw your attention to the difference between where the terms start and stop. That's why I started by putting those plus signs in. This right here is a term, and then I see a plus sign. This whole thing together is a term. Here's a term, here's a term, here's a term, here's a term, here's a term. Should be 7 terms if it's a power of 6. Okay? So now let's look at what's going into our calculator here. I just used my purple marker. Probably shouldn't have, but okay. So this first one, I'm doing 1 times 2 to the 6th power. I know that that's really just 2 to the 6th power, but 1 times 2 to the power of 6. Let's just get in the habit of typing this in correctly. Okay, and I get 64. And then I have x to the 6th power. Okay, in this next term, 6 times 2 to the 5th times negative 7. Okay, so let's think about this one for a minute. Let's just type that in. 6 times 2 to the 5th times negative 7. That should be able to type in just like that. If you have a calculator that when you go to type that exponent and if it puts it up in the corner for you like an exponent is supposed to be, just make sure you use your arrow keys to come back down before you multiply by that negative 7. Okay? But it's negative 1344. The fact that it's negative really means that this plus sign could just be written as a minus. Now, if you wanted to write it as plus negative, that's okay, but just trying to save you some writing here. So 1344. And then, so that took care of all of my numbers. I guess I shouldn't have crossed out that power of 5 because that power of 5 is still belonging to the x as well. So this will be x to the 5th power. My next one, I'm doing 15 times 2 to the 4th times negative 7 squared. Okay, let's type that in carefully. So I'm doing 15 times 2 to the 4th times negative 7 squared. Okay. And I get 11,760. Oh, you know what? On this last one, I missed one. Let me finish writing this in. Maybe you were screaming it through the camera. So this is x to the 4th. I missed that this one also has a y in it. This has a y squared. Back here in this one also had a y. I should have had a y in this term. So, whoops, sorry about that. Glad we caught that. Okay, why don't you take a second and try calculating the coefficient on the next term. So try combining all of those numbers. Just get this number here, okay, when you combine all those pieces, and then we'll do the x and y piece together. But let's just make sure you get the right one. So pause the video, give that a try. What I am typing in for this next one is 20 times 2 to the 3rd power times negative 7 to the 3rd power. And that's, so again, this is another negative, so this is going to be subtraction. 54,880. These numbers get really giant really fast. And then I have an x cubed and a y cubed. Okay. Again, if you'd like to pause and try the next one, might not be a bad idea. $15 times 2 squared times negative 7 to the power of 4 is 144,060. And then we have x squared y to the 4th. Okay, let's keep going. My next term, 6 times 2, and technically that's to the 1st power, and then times negative 7 to the 5th power. So negative 201,684. I'm running out of space here, so I'm going to just continue on down here. So minus, what's that number, 201,684. And this would be an x to the 1st and a y to the 5th. And last but not least, I'm doing 1 times negative 7 to the power of 6. 117,649. And that's with a y to the 6th power. Okay, so calculating those giant numbers is the hardest part about this process, okay? You just have to be real slow and careful. Make sure you're putting parentheses around anything that's being raised to a power, especially if you're working with negatives. I do want to point out something with the negatives. So this was subtraction in the original parentheses. And if you look at the signs on your terms, this one started positive and then negative, positive and then negative, positive and then negative, and so on. The reason that happens that way is those powers of the negative number, the even powers are going to make it turn positive, the odd powers are going to make it turn negative. So like here where we had negative 7y to the 1st power, that term came out negative. But down here where we had negative 7y to the 4th power, that came out positive, okay? That's what the parentheses are going to do for you if you make sure you get the parentheses placed correctly. Now, as complicated as that may have felt, I promise you, this was better than writing out 6 of these parentheses and foiling all day long. Okay? Okay, this next one just says expand using the binomial distribution method, which is what we've been doing. It's actually the binomial expansion method, but we'll ignore that word there. And then it says check your answer using FOIL. So notice this is a problem I could have given you with FOIL, right? And we would have been fine with it with FOIL. But let's just practice it with the binomial distribution. It's an easy one because it's only a power of 2. So we only need row 2 of Pascal's triangle. And row 2 of Pascal's triangle is just 1, 2, 1. If you really needed to go through and generate that, you could. Okay? And then I'm going to take the negative 2x and do it to the power of 2. And then the negative 2x to the power of 1. I guess I don't need to write the 1. And then this one doesn't get a negative 2x at all. And then I'm going to take the negative 3. This one would be a power of 0, so it wouldn't get a negative 3. This one's going to get a negative 3 to the 1st power. And this one's going to get a negative 3 to the 2nd power. Okay, and I'll get my plus signs in there too. This one I can probably do without having to use my calculator to do all of that. So negative 2 squared is positive 4. 1 times 4 would just give me 4. So this is 4x squared. Okay. Here I have 2 times negative 2 times negative 3. Well, let's see, that's positive 6 times 2, so that would be 12. And then I just have an x here. And then here, negative 3 squared is positive 9, so 1 times 9 would just give me a positive 9. So this thing here would be my final answer. If I FOILed this thing, so this is me foiling now, so negative 2x minus 3 times negative 2x minus 3, that would be 4x squared. This would give me a positive 6x this would give me a positive 6x, and this would give me a positive 9. And so if I put my middle terms together, I would have this exact thing. Okay, so this is just trying to show you that essentially you're finding the same answer as if you FOILed. And if it's a binomial square, you know, it's a toss-up which one is easier. I mean, once you get good at this, this might even be faster than FOILing for you. But if you wanted to just FOIL that, that would be okay too. Okay, either one's all right. But if I hand you something to a power of 6, you're definitely not going to want to mess around with that many FOILs, okay, with that many like binomials that you have to multiply together manually. Okay, you won't know if you know what you're doing until you try some of these on your own. So we're going to head off to homework. You know we're going to practice it plenty in class, okay? But I don't think we need to do more examples together right now. I'd like to get you trying some. So you can head off to homework, and I will see you in class for any questions you may have.